Hello, everybody. Welcome to Session 4, our final installment of Vectorworks Marionette Monday. And happy George Washington's birthday to all you people who are Americans. I'm Robert Anderson, Vice President of Integrated Practice for Vectorworks Incorporated. I'm here again with Sarah Barrett, a member of my team and our stalwart Marionette evangelist. I'm really excited to be bringing to Vectorworks users advanced level training on our exciting new algorithmic design platform Marionette, which you guys I hope have all been attending for the first 3 sessions. Today is an exciting day because today we're going to dip our toes into the placid waters of Python scripting. So we've reached the final edition of our regular Marionette Monday webinar series, but this is by no means the end. Last week we learned some advanced Marionette techniques, customizing nodes, adding nodes to a user library for sharing, using symbol definitions of Marionette definitions, conditionals, and analysis. Today's session is part 4, Marionette Advanced Techniques Session 2, where we'll learn some actual Python scripting. This session, like all the others, will be recorded, so you'll be able to go back and pick up all the details. Again, a reminder, we have some great Marionette events planned for our upcoming Design Summit, scheduled for April 25th to 27th in Chicago, so you should make plans to attend if at all possible. For U.S. attendees, this week is the last week to act to get a 20% discount, an early bird rate of $399. I also want to mention that there's another way that this is kind of not the end, and that is that there will be available one-on-one Marionette support sessions for those for anybody who wants it. Will be provided by Sarah Barrett and Marissa Farrell. More details on this will be in your follow-up email to this webinar. Before we start, a few items. The first is that we have a new Marionette page at vectorworks.net. Go to vectorworks.net/Marionette to see our new Marionette resources page, where you'll be able to keep up with all things Marionette. However, my biggest announcement of the day is Marionette Science Fair. This is how to put this? This is a contest. It's a friendly competition of creativity using Marionette to solve a problem, a design problem, hopefully. The entries will be judged by a panel of Marionette experts, and the top 3 entries will receive some pretty nice prizes. First prize is an Apple Watch. So go to www.vectorworks.net/Science Fair after the webinar today to look at the rules and prizes. Once again, please join me in welcoming a valued member of my integrated practice staff, Sarah Barrett, who will be your Marionette trainer for Marionette Monday, Session 4.
Hello, everybody. Give us a moment to switch our screens over. So, hello. Today we're going to learn how to modify the code inside Marionette nodes. The way Marionette is set up, with its code so readily available, the principles you learn from working with nodes can be transferred to working with the code inside. If you are still new to Marionette, this may seem like an overcomplication of an already complex subject, but I promise the more experience you get with Marionette, the more you will want to take the next step into coding. As we talked about in the first webinar, Marionette is built in the coding language called Python, and also includes commands that are from the specific Vectorworks coding language VectorScript. This is what the Python code looks like inside a Marionette node. So I can also see this if I hit the edit button. This is what it shows me in this script editor window, or if I simply double click on the node. So let's go through, talk through what all this means. So the first part dictates the appearance of the node, what its name is, and what its input and output ports are. The blue words refer to modules, or blocks of code, that are located outside the node. Every time you see the word Marionette, followed by a period and then another command, you know that this is referring to a block of code located in the marionette.py document that is in the plugins folder inside your user folder. And I can show you what that file looks like. Marionette.py. So this is just a code document that is kind of like the master document for all the Marionette nodes. It defines a lot of the things that we use all the time in the Marionette nodes. And so when a node is run, it actually goes to this file and looks for the answers it needs from this file. So the other words in blue, class and def, refer to built-in commands that are in the Python language. There are several other built-in commands that you will find often in Marionette nodes. We'll get to a few of those later. The words in green are strings. Whenever quotation marks are used in coding, whatever is inside them can be read just as it is. No other commands or meanings. It's how descriptive text is put into coding. The numbers in this code are in red because they represent absolute values. 0 is always 0, no matter what module or block of code you are referring to. When a line of code is indented, it means that it is dependent on the line of code above. So all of these lines of code are dependent on the line that begins with class and ends with colon. So this first line of code tells us what the name of the node is. This command, Marionette node, is what gives the node its name, and we have the name here in parentheses. These lines tell us the names of the input and output ports. If for some reason you want the name of the port to be different than the variable you give it, then this is how you write it. Inside the parentheses of the command Marionette port in, you put the default value, a comma, and then a string for the name. Input ports always need a default value. Output ports do not. The lines underneath these commands are setting the description of each attribute that will be visible in the description dialog box. These lines are not necessary for the code to function. They are just there to tell the user what the node does. So each of these corresponds to a description within the dialog box. This command, setLinksObjects, shows up in any node that creates geometry. What this line does is attach the created geometry to the node. So when you change a definition, the old geometry is deleted and replaced by the new. Without this line, every time you ran a definition with this node, a new rectangle would be created over the old. There are a few different ways to write commands, and these 3 lines in large font show the most common found in Marionette nodes. The first line is variable equals module.class.value.function. These 4 lines below are creating variables for the values that are flowing into the input ports. What the variables actually are does not matter. I can change these variables to anything I want, but as long as I change every instance of them within the node will still work. As you can see, the module is self, which is another way of, in Python, of allowing a definition to refer to itself. And then class is params, which we saw above here. So basically, it's asking for the value that is inside this class. And then the value is the port in for point, and the function is asking for the value that's coming through that port. I remember when I first learned this, These lines seemed especially redundant to me. I did not understand why they were necessary, but as I learned more about coding, I realized the inherent power of even very simple code, and therefore the necessity of being explicit. Learning this small bit of coding has felt like a logical step from learning Marionette, but it is something I never considered when using other graphical scripting programs. I know it's overwhelming, especially if you're still new to Marionette, but once you break that barrier from graphics to actual code, the new possibilities grow exponentially. So back to the code. The next line here is where the action happens. The module in this line, VS, stands for vector script, which means that the function that follows is a vector script command. A list of vector script commands can be found at developer.vectorworks.net. And as you can see, you can click on each one, and it tells you how to write it in vector script and how to write it in Python. The function creates a rectangle using the variables that are named above. In the second webinar, we learned that brackets are used to indicate lists, and that every value in a list has an index number that corresponds to its position in that list. The brackets after origin and rotation indicate that a particular part of the origin and rotation values are being used. In this case, the origin and rotation values are both x, y coordinates. So they are essentially two values within each. So origin bracket 0 is the x value of a 2D point, and origin bracket 1 is the y value of a 2D point. And the same goes for the two rotation values. The last line of the code defines the value of the output port. In this case, the value is vs.lNewObject, which stands for the rectangle that was created with the last line of code. This vector strip command can be used directly after most commands that create new objects. This could also be written slightly differently. This could be rewritten with a variable and an equal sign before the rectangle command, and then that variable would then transfer to the definition that gives us the value of the output port. And remember, it does not matter what this is. This could be anything. It could be a name. As long as it's all the same, it'll work. Any questions? Is the Marionette PY file automatically created and updated? Yes, it is. It's not meant, you shouldn't be ever really open it to try to edit it, because it will edit all of your subsequent Marionette definitions, but it is available for you to see, just to get an idea of what the nodes are actually doing. Okay, question. Rectangle has double quotes. The next set description is in single quotes. Does it make a difference if you use single or double quotation marks? It doesn't make a difference. The only thing to remember is that if you use single quotes at the beginning, you have to use single quotes at the end, and same with double quotes. So they're really interchangeable as long as they match at the beginning and the end. So do all Vectorworks commands have a corresponding Marionette function? They do, they can. Any command, any vector script command that you can find in this function reference or in the script editor, and I'll show you where that is later, you can put into a Marionette node. Because basically, if you think of the Marionette node as just a package where you can put whatever code you want into it, and it basically runs that code no matter what it is. Okay, so let's try making some of our own nodes. So remember the pair wall from last webinar? The wall where we had the randomly generated holes. There was a custom node that we used at the end of the definition called setName. We used it to give our wall a name so we could attach it in a later definition without having to rerun the pair wall network. SetName node is based off of a standard vector script command that just happens not to be in the standard node library. So let's go through how to write it. We don't have to start from scratch. We can use a node that does something similar and Frankenstein it with our own code. So since it's a set function, we can go to Marionette and find a set function node, set height, and then double click. The first thing I do whenever I'm changing a node or writing a new node is change the name. That keeps it from being confused with original versions of the node. So change it to set name. As you see, changes the name of the node. So these also, sometimes I change them, sometimes I don't. It depends on how thorough I want to be. So let's go through and change them. Sets the name of past objects. And then name to give the object. Result object with its new name. So right now these are the variables that are on the outside of our node. Object and height. So we want to change height to string because that is what the input is going to be for our name. So since we changed this up here, we have to change this command that gets the value from that port. So now we see that the output port is a string. So now we basically need to just replace this command with the setName command. So the way I can do that is I could go to that web page and I could copy paste, or I can click on this drop-down menu in the script editor dialog box, go to procedure, and now I have a list of all the vector script functions. So let's go to object names. So we want setName. Select that, hit OK, and it pastes it right there in your dialog box. So now I just have to make sure the variables match. If we go back and see what this node is asking for, it sets the name of the reference object, and it doesn't say it here, but I can tell you that the H stands for the object, and then name stands for the string of the name that will be given. So our object has been given this variable name, and our string has been given this variable name. So now let's just delete that old. So now we've written a new node that now sets the name, or at least should set the name of this wall. So let's try this new node. So let's change the name to wall random. And then run the script. Remember, this script takes a minute. So if we go to our geometry, and we select our wall, we can see that it now has the name wall random. So let's go to another definition that we looked at back in the first and second webinars. If we remember, this definition created a point grid inside a poly. And then in the second webinar, we changed the point grid to only show points outside the poly, like this. So, and we did that by adding these 4 nodes. And I remember I said at the time that it's a lot of nodes to simply switch this Boolean value from true to false. And there's a super simple way to do this with a little bit of coding instead of adding this if node with false equaling true and true equaling false. So if we delete this and we connect the Boolean to the filter node, double click on the filter node, and if we look at the code here, it says if self.params.bool.value, then the out value of the output port is the item from the input port. So basically what this is saying is if true, then this happens. Else, this happens. So we simply want this to say, instead of saying if true, just say if not true. And now it will give us the false values. So all I did was add 1 word in the code, and that's how it changed the definition. Any questions at the moment? How does the scripting language know where a block of code ends? Example, Java has curly brackets. Python has indentation. So basically, anything indented after this line refers to that line. And same as this line has a line of code indented behind it. So when it comes back to being not being indented, it goes back to the indent above it. I'm calling the variable string. I would call it name. Can you do that? Yes, I can do that. So let's go back and change it. I just used the word string because that would signal which node I wanted, that I can change it to name. Now, I don't necessarily have to change this variable because this is not referring to the outside of the node. I just needed to change this one, and this one. So now it says name. How would we know that H equals object and name equals string? Is this defined somewhere? Yes, it's defined in the node script. It's not necessarily when you look at the lines of vector script commands online or in this drop-down menu. It doesn't define the variables. It just tells you what variables you need. So you need to define the variables before you run this function. So inObject has been defined as this, which is referring to whatever is coming through the input port that has the name object. And then likewise, this is referring to whatever value is coming through this input port. And as you can see, the default here is listed as 1 from the old node. We could just say, have it be name, and then when I put it in quotes, it makes it a string. And so if I detach this and run it, it will give the wall the name, because that was the default value in the node. Okay. So Marionette can not only manipulate objects within a Vectorworks file, but also import objects into the Vectorworks file. If there is a Vectorworks script or Python command that can do something, Marionette can likely do it too. The reason this is possible is because every Marionette node is simply Python code. The nodes only perform operations within the bounds of Vectorworks commands because that's what we've been telling it to do. If you want to access something outside of Vectorworks, you just need to tell Marionette where to look for something. So let's look at this script. So this script goes out to the internet and using the Google Static Maps API, obtains an image from Google Maps of the latitude and longitude, then imports the image as a bitmap. It then rotates and translates the bitmap to the Heliodon location. Maps are limited by Google to be 640 by 640 pixels, but you can play with the zoom factor and map type in this definition in order to change the style of the map. So what this is based on is it is getting information from this Heliodon symbol and then using that information to build a URL address. And if we look at the URL that's built, this is what comes out of these two nodes based on these strings going in. And if we copy this, go to the internet, paste, this is what we get. So this is what this function is importing into the file. But first, before we get this to work, we need to know what the record values and field names and field values are for the Heliodon plugin object. So when you place a Heliodon into a drawing, you go to settings, and here you can change the different settings to be whatever you'd like. Or you can even type in the latitude and longitude. So the problem though is if we look at the OIP, we see that, get this out of the way. We see that all of this data is formatted very nicely in the OIP for us to choose and change. But if we go to the data tab, we don't see any records. So the record for this object is hidden because normally we wouldn't need to edit it anywhere but in the OIP. But we are going to need the native data of the Heliodon's record in order to do this definition. So I've already created a definition that prints the list of field names and field values from the Heliodon. But And it was actually relatively easy because even for a newbie coder like me, the necessary commands already existed in VectorScript. I just had to put them in the node. And we'll go through the node and I'll show you step by step what I did. So, double click on the node and we can see that I've used get parametric record, get name, which is the counterpart to set name, num fields, get field name, and get record field. And this function already exists in another node in the standard get record field node, but since it's asking for a record name and a field name, I wasn't able to use that node. So, and since I'm finding the record name and the field name within this code, I figured I might as well just add this and use it within the same node. So, there is a way to write notes to yourself when you're coding, and that have no bearing on what's actually happening in the code. They're just for your own personal use. And the way you can do that is by typing pound, or as some people now call it, hashtag symbol, and then typing. And this has no effect on the code. It's just for your own use. So what I'm going to do is I'm actually going to go through each one of these and talk about what it's doing by commenting next to it. So, okay, this line, object, creates a variable for the input object. This command returns a handle to the hidden record of that object. Now, if this was the only part, if this is all I did with the code, and then I had this be what comes out of my node, it wouldn't necessarily be very useful because it's still not in a form for us to read it. So I've attached the record to this node, but now I need to get information from it. So then this line returns the name of the record. And then this next line gives the number of fields that are in this hidden record. And then this is where it gets a little interesting. This line creates a range of numbers that are going to represent each field. Or sorry, this creates an empty list that we will then add to later. So that's all this is just creating a variable and then using two brackets to create an empty list. So then this next line, for x in range 1 to fnum plus 1, is basically creating a list of values that range from 1 to however many field names there are. So gives a range of numbers representing the indices of the fields. And so then this next line gets the name of each field. And this line takes those names that were created here and adds them to this list that we started up here. It took me a while to figure out why this was necessary, but for now, just go with it. You'll figure it out soon enough. So this adds the values above to the list field name. So now we do this again with the field values. So we create an empty list. And then this is giving us, just like last time, this creates an index number for every item in the list field name. And so this line gives the value for each field. And as you see, next to field name, we have brackets and the I here. So basically what this is telling us is that we want the value of the record with this object record with this record name and the field name with index 0. And then do it again, index 1, again with index 2, and so on and so forth. So now that those values exist, we have to add them to the empty list we created earlier. And so then these last 3 lines, as we've seen before, just name the values that will go through the output ports. Oops. And so I can close up this node and it runs the same as it did before, even though it has all this text in it. It doesn't have any effect on the script. So if we attach this to these 3 dummy nodes and we take this object by criteria node, we can see that we have 2 heliodons in our drawing. Let's delete 1 heliodon just for clarity's sake. So now we see that we have 1 heliodon, and that the heliodon record has 59 fields, and then 59 values for each field, 1 for each field. So in order to get a handle to our heliodon, I used an object by criteria node. And when we've used that before in the webinars, we've used the format T equals, and then RECT for rectangle, poly for polygon, polyline for polyline. But we need to be a little more specific here because the object type of a heliodon is a plugin object. But if we just wrote T equals plugin object, then we would get a handle to every plugin object in the document, which would include all of our Marionette nodes. So we don't want that. We want the specific plugin object that is called a heliodon. So the way we do this, instead of doing T equals, we do PON, which stands for plugin object name, equals heliodon in quotes. And we know it equals heliodon because if we look at this, we see in the OIP that it has this name up here. So this is the plugin object name. So if I wanted to find a different plugin object in my document, let's put something completely random, like a wall cabinet. N, so you can see it's called wall cabinet. If I change this, run it, you can see these have updated, and there are 33 fields within this hidden record. And here are the values of the wall cabinet in its default mode. So let's change this back to heliodon. And then let's look at this wrapper. So this wrapper takes that get parametric record node that I created and takes the lists of field names and values and zips them together and then chunks them into separate lists of 2. And then, so a separate list of 2, and then adds a equal sign in between the 2 values in each list. And then here, I insert the record name into the top of the list and then print the record. So this is going to give me a text object with the list formatted in a way I can use for reference. So here's the hidden record for a heliodon with all of its field names exactly as they are written, and all the values that are editable in the OIP. So now that we have this for reference, we can go back to the main definition. And we go into this wrapper, we see that I have used the record name that I found from that list, as well as these 4 field names in order to get the proper field values. So what's happening here is, for example, this little wrapper is taking the letters either N or S for north or south, and changing them. So this is saying if this is equal to south, then if it's true, put a negative sign in front of the number, or put a positive sign in front of the number. So basically it's just formatting this so it will build the URL exactly as we need it. And so you can also see that some of the string inputs for this URL are named, and these are the ones that we can actually change in order to change the map. So zoom value is currently 11. You can zoom in a little more, change it to 15. And I run again, and you see that the map has zoomed in closer. Say, instead of seeing a road map, I want to see a satellite map. So now we have the satellite map that comes from the Google Maps API. And I can still change this heliodon to some other city. And then run it again. Now we have Amsterdam. So, any questions? Is Python case sensitive? Yes, it is. Basically, you can think of it like a password. Everything has to be exactly, here, let's go in here. This is different than, say, this is not the same command. So, yes, cases are important. But when it comes to making variables, you need to match the cases, but like this doesn't necessarily have to be like that. I mean, if this can be in all caps. As long as I change it everywhere else, it should work. Oh, this one here. If we want to see what it looks like, if we put on the outside, we can take out that string name. And see we have it in all caps on the outside of the node. Naming convention is that functions start with a capital letter for the first word, but variables in lowercase. As I said, that's just what these definitions are using, but you can do it any way you want. So I recreated all the VS calls in Python and named them VS. VS whatever.
So that's what we do for the API.
So I'll explain why. If we go back to the developer page, and we look at this, is how you would write active class in VectorScript. But if you're using the coding language Python, you have to first tell Python that you need to go into the VectorScript library and find this. So that's why there is a VS before every command from VectorScript. So basically it's just telling Python, go and find this command here, this is where the command is. Okay. Oh, where are the best places to learn the basics of Python? Would doing that be a bit of overkill for the purposes of using Python with Marionette? No, it would be awesome. I go there all the time. So as you can see, I have it bookmarked. So this is the Python standard library that will tell you all the built-in functions that are in Python. So if you typed in this function, you would not need to type anything before it, like VS for the Vectorworks command. So it gives you an explanation of all of them. Sometimes it gives you examples. And then the other great way to find information is simply to type in a question. So how do I make a list in Python? And this will take you to either this Python documentation or the Stack Overflow blog is where a lot of people ask questions about Python and get answers. It's my favorite place to go to figure out how to do things. So I recommend just typing your question into the search menu and following the links. Okay, so back to this. The way this image was imported was basically from this node. And looking at all of this part of the code is basically formatting the URL in order to have it be just right for it to work with this command, which is a vector script command that imports an image file. So this is really all this node is doing. Everything else in here is just making sure that the URL takes you where you want to go. So I can use that to, say, bring a screenshot into Vectorworks. For Mac users, screenshots are often done by using the Command Shift 4 or Command Shift 3, which gives us a whole picture of my desktop. And then, as you can see, these screenshots automatically get placed on my desktop with a name giving their time and as a PNG file. So if I want to bring screenshots into Vectorworks, I have to, normally I'd have to go to File, go Import Image File, and find the file. So I decided to write this node that basically what it does is it goes to the desktop of any of my computer, and then it looks for, it finds the list of objects or items that are on my desktop. This line says that we only want to look at the files that have PNG at the end. And then here, basically I'm saying I want the most recent file by getting the file time and then saying max. So then what this will do is this will import the most recent screenshot that I took. So if I take another one, run it again, it brings it in. So as for PC users, I don't necessarily feel bad about this not working for PC users because the basic way to get a screenshot for PC users means that it saves it to the clipboard so that once you take a screenshot, you can just go back into Vectorworks and do Control-V to paste it into your document. So are there any more questions? Okay. That concludes our webinar for today. Please visit our website to look at the science fair.
There are two pages to go to on the Vectorworks website, vectorworks.net/Marionette and vectorworks.net/sciencefair. Take a look at them both, and you'll find all the resources that we've been referring to today. And I think there's still a little bit of development work to be done on Science Fair, but take a look at it over the next couple of days, and you'll see what we have available for you.
Thank you all very much.